Assalamualaikum and good day to all panelists and viewers. I'm NURSHAFANINA binti AZIZUL. For today, I will present my FYP entitled Electrical Discharge Coating of My Steel with the inclusion of titanium dioxide powder. Firstly is introduction. Electrical discharge coating is the one of the surface modification technique that provide a great capability to repair and improve the surface properties of the workpiece. It able to enhance the characteristic of the workpiece, which is our substrate, my steel, in terms of hardness, roughness, corrosion, and wear resistance. EDC process was conducted by using EDM die sinking machine. This process is same, but only the difference is a polarity. EDC process is used negative polarity in order to provide a coating to enhance the surface properties of the workpiece. EDC process require the dielectric fluid to coat the electrode and the fluid at the surface workpiece. EDC process consists of two major methods, which are PM-EDM method and PM-electrode method. Next, continue to the problem statement. As we know, my steel is a versatile material which is widely used in most engineering applications for production of automobile components, structure shape, and sheet that are used in plant, engineering facilities, pipeline, and building bridge. The mild steel properties contain low hardness due to the less value of carbon content. It will lead to the accumulation of hydrogen atom that can cause oxidation matter. The major problem of mild steel is easy to be corroded when exposed to the environment due to the degradation of metal material, and it will lead to the failure to be operated due to the rusting. The objective of this research is to investigate the effect of electrical discharge coating (EDC) parameters such as discharge voltage, peak current, and pulse on time on the surface roughness and material deposition with the inclusion of the titanium dioxide powder. Next, proceed to the scope of the research. The method that has been selected for this research is PM-EDM method. PM-EDM is discussed about the mixing of powder into the dielectric fluid to form a mixture. The suspended agent has been selected is titanium dioxide powder. It consists of great properties which has high thermal expansion, which are very important to prevent excessive stress or strain which can lead to the rusting. Next, it contains high hardness, high abrasion resistance, and high melting point. The workpiece that has been selected for this process is my steel, and the electrode used is a copper rod. The parameter that will modify is voltage, peak current, and pulse on time. The RSM matrix of parameters selected will be generated by using response surface methodology in Minitab software. The output or measuring response that will be studied is surface roughness and material deposition. The surface roughness will be analyzed through RSM in main effect plot. This shown the literature review of surface modification. The surface modification of EDC is using reverse polarity, which is workpiece connect at the cathode and the electrode connect at the anode. The PM-EDM method, which using powder suspension, can be enhanced the surface finish by reduce the micropores and microcrack. This is literature review based on surface roughness and layer composition. What can I conclude from this literature review is peak current and pulse on time play an important role compared to discharge voltage to controlling the electrical spark discharge. The material deposition will show the material that attached at the coating surface after experiment. The parameters such as discharge voltage, peak current, and pulse on time play an important role to determine the material deposition on coating surface. Continue to the methodology. In this section, the flow of experiment will be discussed in detail. The process starts by preparing the mixture. Low-smell kerosene oil will be mixed with the titanium dioxide powder and C-type surfactant to form the electric fluid. In order to make sure the mixture is mixed well, the labosonic ultrasonic homogenizer will be used for mixing process. Time taken to mix the kerosene oil with surfactant is 5 minutes, and after that continue with titanium dioxide powder for 30 minutes. The powder concentration used for this experiment is 10 gram per liter. The value of titanium powder and kerosene oil used is based on the equation calculated. Then define the parameter of study. RSM method will be used in order to determine the parameter by generating the RSM matrix in Minitab software. The design of level selected is 3 and the factor selected is 3, which is discharge voltage, peak current and pulse on time. The type of RSM selected is both bank can design because the number of run is least compared to CCD. So, the less time taken is required to finish the experiment, and it also can reduce the cost. The total number of run is 30 with a 2 replication. The function of replication is to prevent the noise during the machining process. This is machining process during the experiment. Firstly, electrode will be ground by using grinding machine with a sandpaper. The function of grinding process is to make sure the copper rod gain a flat surface. Next, the workpiece was clamped in a tank and the dielectric fluid is poured into a tank. The tank is attached with a pump in order to provide a better circulation of dielectric fluid. The machining time for each run is 30 minutes. It repeated for a 30 run. Then continue to measurement using for collecting data. The surface roughness tester used to determine the reading of surface roughness after experiment. 3 reading data at different points is taken and the average reading will be calculated to increase the accuracy. The average length of diamond is set up to 0.44 mm. Next, the XRD is used to scan the deposited element that have in electrode, dielectric fluid and titanium dioxide powder on the surface coating. This is a result and discussion for surface roughness. The data shown 3 reading at different point has been taken and average reading has been calculated. The surface roughness will be analyzed using RSM method. The table shows the RSM matrix generated by the Minitab software. In the table, it includes the input parameters such as discharge voltage, peak current and pulse on time, and the output response, which is surface roughness. The surface roughness will be analyzed in RSM. The table shown the ANOVA analysis for the surface roughness. The statistically significant was set up by p-value. The level is at below 0.05. Based on the table, linear and square has very significant term at p equal to 0.000 and square at p equal to 0.0002. Moreover, the F value of a model was 14.81, which indicate there is no chance that F value occur. However, from this model, only peak current, pulse on time and voltage is significant, but voltage is insignificant. The current shows the highest F value because the current is the most significant due to value of the surface roughness significantly increase when the peak current increase compared to others. The p-value lack of fit is 0.1969. This proves that the p-value is insignificant and it proposes a good fit to the average of surface roughness data. Next is response surface plot. The voltage increase and pulse on time increase when the surface roughness increase. Second, the voltage increase and the peak current increase when the surface roughness increase. Lastly, peak current increase and pulse on time increase when the surface roughness is increased. Then, the effect of parameter towards the surface roughness response will be discussed based on main effect plot. Firstly is the effect of voltage toward the surface roughness. The highest the surface roughness was achieved at 40 volt. This is because the voltage able to increase the size of spark gap between the electrode and workpiece, which will enhance the flushing condition for the removal debris and material deposition. So, the crater will form and the surface roughness will increase. Next is the effect of peak current towards the surface roughness. Increase the peak current will increase the surface roughness. This is because the higher value of the current used, the spark energy discharge is increased. Hence, more material will melt on the workpiece surface, cause ununiform of surface coating. So, increase the surface roughness. Lastly is the effect of pulse on time toward the surface roughness. Higher value of pulse on time, the higher value obtained by the surface roughness due to the high impulsive force, which can lead to the high spark energy. Hence, more material melt is removed and lead to the formation of crater. Next is study about the effect of machining parameter towards the material deposition. The average weight of material deposition was analyzed using EDX analysis. Based on EDX, there are 6 elements was found which are carbon, titanium, oxygen, iron, copper and zinc appear on the surface coating. The presence of copper element indicate that the material has been transferred from electrode, and presence of Ti element is a form from a powder suspended material to the surface coating. According to the research, which is surface modification of mild steel by using EDC with the inclusion of titanium dioxide powder. Hence, the percentage weight of material will be focused on titanium element only to be analyzed. Firstly is the effect of voltage toward percentage Ti element. In this part, voltage value will be modified, but the other 2 parameters will be constant. The graph shown that the inverse proportional graph, which is increase in voltage, will decrease the weight of titanium element. This is because increase the voltage cause the spark gap increase. It will increase the electrical field strength that cause the poor material deposition on workpiece surface. Next is effect of peak current toward the weight percentage of Ti element. The graph shown the directly proportional, which means increased peak current will increase the Ti deposition. During the higher peak current, the electrical discharge is at high peak and produce more electrical spark. Hence, more material will be made at the workpiece surface. Lastly is when the value of pass on time is increased, the weight of titanium element decrease due to the size of plasma channel increase when the pass on time increase. Hence, the distance traveled by the material will increase. In consequence, the material deposition will reduce. Lastly is conclusion. What can I conclude from this research is, after EDC process, migration of material from titanium dioxide powder and dielectric fluid result in deposition of material on workpiece surface. Presence of 6 elements prove that the material has been transferred to the workpiece surface. Next, the best parameter to reduce the surface roughness is 30V, 3A and 100 µS based on main effect plot in RSM. Lastly, the parameter is most significant input in order to control the response. Based on this finding, the higher the voltage will result in higher surface roughness and lower deposition material. Second, the higher peak current will result in higher surface roughness and high material deposition. Lastly is higher pass on time will cause higher surface roughness and lead to the low material deposition. That's all from my presentation for FYP2. Thank you for hearing and Assalamualaikum everyone. Stay safe.